Alright guys, so this is the video for section 11.6, and as you can probably guess by the picture on the screen, we're going to be talking about pyramids. Okay, so the volume for a pyramid is right here. Okay, it's 1/3 area of the base times the height. And when I mean the height, I mean the straight up and down height, not the slant height, straight up and down. Okay, so once again, because pyramids can have various different shapes of bases, the formula that goes in here will be different depending on the shape of that base. All right, let's do an example. Okay, here's a pyramid here, and here's the base. Okay, so the base is a triangle. So the volume of this period is going to be 1/3 area of the base times the height. Okay, well, we know the height is 9. Okay, now I'm just going to find the area of this base. So the area of the base is going to be 1/2 times base times height of this highlighted triangle. Okay, so the base is 4, height is 6, so 1/2, 4 and 6, which is 1/2 times 24, which gives me 12. Okay, so the area of the base is 12, so I'm going to plug 12 right in here. Okay, well, if you plug this into your calculator, you should get, that's 36 meters cubed. All right, I want you to go ahead and do this one on your own, and then we'll do example 2B together because it's a little more difficult. Okay, but do this one on your own, then we'll go over it. All right, so you're going to use the volume equals 1/3 area of the base times height. You can see here that the height is 12. So now all we need to find is the area of the base. Well, the area of the base, guys, is just this, and you can tell that it's a square because each of these sides have similar hash marks. Okay, so this is 10, 10, 10, and 10. So to find the area of a square, we just do length times width, so 10 times 10, which is 100. We plug 100 in for area of the base. You should have gotten 400 centimeters cubed. All right, let's look at this triangle. Okay, so the area of the base down here is a hexagon. So volume equals 1/3 times area of the base times your height. Okay, well, our volume 1/3. Now the area of a regular hexagon is 1/2 times apothem times perimeter times my height, which is 20. All right, this requires a little more work. So I'm going to go ahead and draw this hexagon. Okay, this is 12, all the way around is 12, right? And so if I draw this central angle here, I can find the measure of the central angle, so right here, by taking 360 divided by 6, because there's 6 central angles, which gives me 60 degrees. Okay, so now I want to cut this in half. Okay, and when I do that, I get this triangle here. Okay, so my 12 now becomes a 6 and a 6. So here's 6, and this is my apothem that I want, and then I cut the 60 degrees in half, so there's my 30. Okay, so we're left with a 30, 60, 90 triangle. Okay, and so we know that this long leg is the short leg times square root of 3, so this is 6 square root of 3. If you didn't remember that, you could use trig to find it. So the area of this is 1/2 times apothem times the perimeter, which is 1/2 times 6 square root of 3 times the perimeter is 12 times 6, which is 72. Okay, and if you put that into your calculator, you get roughly 374.1. Okay, so if I come back up here, 1/3, 374.1 times 20. Put that in your calculator. You should get roughly 2494.2 centimeters cubed. All right, let's look at example 3 here, the dreaded word problem. Okay, so supposedly, and I have no idea how to say this pyramid had a height of 144 meters. Okay, and it also had the volume of 2,218,800 cubic meters. Find the side length of its square base. Okay, so let's set up this equation. All right, so we know that the volume equals 1/3 times the area of the base times the height. Okay, well, the volume here, guys, 2218800 equals 1/3. We don't know the area of the base, and we know the height is 144. Okay, what we do know is that the base is square. Okay, so if we have a square base, we let this be x, 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 all sides are the same. I could find the area of this by just x squared. All right, so now let's just do some algebra. So 2218800 equals, well, 1/3 times 144 is just 48x squared. Okay, to get x by itself or x squared by itself, let's divide both sides by 48. So 2218800 divided by 48. Put that in my calculator. I get roughly 46225 equals x squared. To undo a square, you take the square root, and you would get that x is 215, and that would be meters. Okay, so the square base would be 215, 215 all the way around. All right, I want you to go ahead and work through example 4 on your own. Use example 3 to kind of guide you, and then we'll go over it. All right, so 1/3 area of the base times height gives you the volume. So when you plug in the volume, which is 75, and then you plug in the height, which is 9, the area of a square, once again, is x squared. And then you just do some algebra, and you should get the sides of the base is 5 meters. All right, let's look at example 5. Okay, we still have a pyramid, so we're still going to use volume is 1/3 area of the base times the height. And here we need to find the height. That's what we don't have. Okay, so it tells us the volume is 24. So 24 equals 1/3. Now to find the area of this base, guys, this just has a triangular base. So the area of the base is 1/2 times base times height of this triangle, which is 1/2. Here's my base, which is 6. My height, which is 3. So 1/2 times 18, which is just 9. Okay, so 1/3, the area of the base is 9 times my height, we don't know. Okay, so this is just 24 equals 1/3 times 9 is 3h divided by 3 on both sides. My height has to be 8 meters. All right, let's look at example 6a. Okay, so we should know how to do this. Okay, so these are similar. So I want to find the scale factor. So the scale factor in one dimension is 8 to 6, which is 4 to 3. Okay, but now I'm going to volume, which is 3-dimensional. Okay, so in order to go to volume, I have to cube this. Okay, so the scale factor in 3 dimension is 4 cubed over 3 cubed. And 4 cubed is 64. should be a 3 over 27. Okay, so my scale factor in 3 dimension is 64 over 27. So I'm just going to set up 64 is to 27 as the area of the big is to the area of the little. Okay, now I just need to solve this. So 96 times 27 equals 64a. Divide by 64. So 96 times 27 divided by 64. I get A equals 40.5, and that would be meters cubed. All right, use example 6a to kind of guide you, and then I want you to go ahead and do this one on your own, and then we'll go over it. All right, so you have the scale factor for one dimension. It's 9 over 3 or 3 over 9, whichever, which reduces to 1 over 3 or 3 over 1. Okay, and then to find it in three-dimensional space, you take it to the third power, so you get 27 over 1. Okay, so 27 over 1 is 2. Since the bigger number is on top, you put the bigger area on top. So if you would have had 1 over 27, you'd have put A over 324. But I did it the other way. And then when you cross multiply 27a equals 324, you get the area of the smaller one is only 12 meters cubed. All right, I want you to go ahead and try this one on your own. We're going to find the volume of the composite solid. So what we're going to do is we're going to find the volume of the cube, and then we're going to add it to the volume of the pyramid. And when I do that, I get the volume of this whole thing. All right, so you got the area of this square is just length times width times height, okay, which gives us 216. And then the length of this pyramid, now notice the 6 by 6 square is the base, so the area of the base is just 6 by 6. So the volume of the pyramid is 1/3 area of the base, which is 36, times height, which is 6, so you get 72 for the area of that base. So the volume of this composite figure, you would add the 216 and the 72, and you would get right here 288 meters cubed.